A plain glass plate at 600 Celsius degree is cooled by passing air over it. In order for the glass not to crack during the process, the temperature gradient inside the glass should not exceed 15 centigrade degree over millimeter. If the heat transfer coefficient of the glass is 1.4 watt over meter Kelvin and the surface radiation ratio 0.8, what should be the minimum temperature of the air? The temperature of surrounding can be taken as equal to the temperature of the air. First of all, we need to define given values and energy balance equation, which includes heat transfer mechanisms. Let's start with define values. Firstly, I have surface temperature of glass is 600 Celsius degree and heat convection coefficient is 5 watt over meter square Kelvin. And temperature gradient, what was the temperature gradient? dt over dx, right? And it's 15 centigrade degree over millimeter. And the heat conduction, so K value is 1.4 watt over meter Kelvin. And the radiation ratio is 0.8. So I defined given values. Next, I must define heat transfer mechanisms. What were the heat transfer mechanisms? Conduction, convection, and radiation. If we check the question, we have already hot glass surface and it's cooled by air passing over it. So here there are both conduction and convection. From that, and also, by the way, there is radiation. My energy balance equation becomes Q conduction equals Q convection plus Q radiation, right? And let's write the equations. Q conduction is minus K dt over dx equals to H times T surface minus T surroundings plus epsilon Stefan-Boltzmann constant T surface power 4 minus T surroundings power 4. So let's substitute the values. And dt over dx, the gradient sign becomes negative as the temperature decreases towards the surface, so it's negative. And we convert the millimeter to meters. Minus 15,000 centigrade degree over meter equals to 5 watt over meter square Kelvin equals Ts value is 873.15 Kelvin minus T surroundings plus epsilon 0.8 and Stefan-Boltzmann constant 5.67 multiplied by 10 power minus 8, and its unit is watt over meter square Kelvin power 4. And if you write the Kelvin, 873 power 4 minus T surroundings temperature. And if you solve the mathematical equation here, you will find 680 Kelvin, which means 345 Celsius degree.